if the wronskian W of f and g is t square et, wronskian is given, and if f is t, one of the functions is given. Now we need to find the other function g, and we know that wronskian of two functions at any point t is given by those two functions on the first row and their derivatives in the second row, which is f g prime minus f prime g. Okay, this is what wronskian of two functions. So that is in this case. So let me write this first. F g prime, f is given t, so t g is on this is to be determined. Okay, this is unknown. T g prime minus f prime, the function f is t, so f prime is derivative of t is just 1, g unknown, equals, that's the wronskian, and wronskian is given t square et. So we have a first order linear ODE. So this is just g. Let's divide through by t. So this is dg over dt, by the way, prime means, minus 1g. No, we are dividing by t. So we are dividing through by t. So we get 1 over t, g equals, divide by t, t et. So a linear ODE in g with respect to t. Okay, to solve this we find an integrating factor mu, that is given by e raised to integral pt. I mean, this is the function that's in the place of p, so negative 1 over t dt. Okay, let's find it. A negative outside ln t, and we can take t positive, so don't have to put absolute value, and this is same as e ln t. Here is negative 1, you want to put here. Okay, it's negative 1, you want to take here, that's t raised to negative 1. Now we can cancel e and natural log, I mean their actions cancel, so this is t raised to negative 1. Inverse of t means just 1 over t. Okay, now we multiply this ODE here, star, we multiply by this integrating factor, then we get multiply star by the integrating factor, which is in fact 1 over t. We get the left hand side will be automatically derivative of the dependent variable, which is g t. I mean, this is given in terms of a function of t, g times the integrating factor 1 over t, that's the left hand side, is equal to let's multiply the right hand side here by 1 over t. 1 over t and t cancel, just leaves e raised to t. Now we integrate both sides, okay, with respect to t, obviously. This dt, here is dt. When we integrate, just this survives, g times 1 over t equals, antiderivative of et is just et plus some constant c, and to isolate g, this is 1 over t, so we can multiply through by t, and we have already said t is positive. Here we can take t positive, multiply through by t, we can because t is not 0. Then this is g as a function of t equals multiply by t et plus ct. Okay, or we can take c equals 0 and just tet. That is also an answer, final